Close your eyes now and imagine rain. Not the harsh downpour that drums against windows and floods the streets, but the gentle, persistent rain that falls in the deep hours of night. The kind of rain that whispers against leaves and stones, that seeps into the earth and brings life to sleeping seeds. The ancient peoples of the world knew this rain well, and they looked to the heavens to understand when it would come, where it would fall, and what it meant for their survival. They watched the stars with an intensity we can barely imagine today in our illuminated cities where the night sky has become almost invisible. But in those ancient times, the stars were not merely beautiful. They were essential. They were guides, calendars, and storytellers all at once. Among all the patterns that human eyes have traced across the darkness, one small cluster of stars held particular significance for cultures separated by oceans and centuries. We know it today as the Hyades, a gathering of stars that sits within the constellation of Taurus, the Bull. Even now, thousands of years after the first observers gave these stars their names and stories, the Hyades continue to shine in our night sky, unchanged in their essential nature, though our understanding of them has transformed completely. These stars, which our ancestors called the Rainmakers, the rainy ones, the bringers of storms and seasonal showers, have watched over humanity's long journey from firelit caves to electric cities. And tonight, as you prepare to drift into sleep, let us journey back through time and space to understand these celestial companions, to hear their story, and to see how the simple act of looking upward has shaped human civilization in ways both profound and subtle. The Hyades are not difficult to find if you know where to look. On a clear night, far from city lights, step outside and turn your face toward the constellation Taurus. The cluster forms a distinctive V-shape, a pattern that ancient observers compared to many things. The face of a bull, the branches of a tree, the open arms of dancing sisters. The brightest star in this region, the one that seems to anchor the entire pattern, is Aldebaran, glowing with a warm, orange-red light. But here we must pause and acknowledge something that fooled observers for thousands of years. Aldebaran is not actually part of the Hyades cluster at all. It merely appears to be part of the group because it lies along the same line of sight from Earth. Aldebaran is much closer to us, a foreground star that happens to align with the more distant cluster. The Hyades themselves lie approximately 153 light-years away from Earth, a distance that seems both intimate and incomprehensible when we consider the scale of the universe. The name Hyades comes to us from ancient Greece, though the stars themselves were certainly observed and named by cultures that preceded Greek civilization by thousands of years. In Greek mythology, the Hyades were sisters, nymphs who were transformed into stars as a reward for their devotion, or perhaps as consolation for their grief. The exact details of the story vary depending on which ancient source you consult, as mythology tends to flow and change like water, taking different forms in different vessels. But the core of the story remains consistent across the variations. These were sisters bound together by love and loss, placed in the heavens where they would shine forever as a unified family. The Greek poet Hesiod, writing in the 8th century before the Common Era, mentions the Hyades in his agricultural poem Works and Days, a practical guide to farming that interweaves mythology with seasonal observations. Hesiod tells his readers to watch for the rising and setting of the Pleiades and the Hyades, using these stellar events to time their planting and harvesting. When the Hyades rose before the sun in the eastern sky, just before dawn, Greek farmers knew that autumn rains were approaching. When the cluster set in the west at dusk, they understood that summer's dry season had arrived. This practical application of stellar observation cannot be overstated. In a world without printed calendars, without precise timekeeping, and without modern meteorology, the stars provided the only reliable method for anticipating seasonal changes. The lives of entire communities depended on this knowledge. But let us return to the name itself, because language carries within it the accumulated wisdom and observation of countless generations. The word Hyades likely derives from the Greek verb hyein, which means to rain. The Romans called them succuli, meaning the little pigs. Perhaps because pigs were associated with moisture and wallowing in mud, or perhaps because the cluster's shape reminded observers of a group of piglets nursing. In Latin literature, the phrase Hyades pluvii appears repeatedly, directly translating to the rainy Hyades. The Roman poet Virgil, in his Georgics, describes how the setting of the Hyades brought storms that threatened sailors. The Roman natural philosopher Pliny the Elder, in his encyclopedic Natural History, discusses the Hyades as reliable predictors of weather patterns, noting that their appearance often coincided with rain and storms. This association between the Hyades and rain appears not only in Mediterranean cultures but around the world, in civilizations that had no contact with Greek or Roman tradition. Consider this. The ancient Chinese astronomers incorporated these stars into their system of lunar mansions, calling them Bai, which translates roughly as net or rabbit net, and they too associated this asterism with moisture and cloudy weather. In Babylonian astronomy, which predates Greek astronomy by more than 1,000 years, tablets preserved from the library of Ashurbanipal contain references to star groups that scholars believe correspond to the Hyades, and these texts connect the stars with seasonal rains and agricultural cycles. The Maori people of New Zealand called the Hyades Matariki, though this name is more commonly associated with the Pleiades in modern usage. Various Polynesian cultures recognized this star group and incorporated it into their navigational systems, using it to time voyages across the vast Pacific Ocean. What does it mean that cultures separated by such immense distances and time periods all independently associated these particular stars with rain and moisture? It speaks to the reliability of observation, to the human capacity for pattern recognition, and to the real astronomical phenomenon at work. The Hyades, for observers in the northern hemisphere, rise heliacally. That is, they rise just before the sun in the morning sky during the late spring in ancient times, and their setting in the evening coincided with autumn. These seasons aligned with rainfall patterns in many regions around the Mediterranean and Near East. The stars themselves did not cause the rain, of course, but their position in the sky served as a reliable indicator that the season of rain was approaching or ending. Over generations and centuries, this correlation became deeply embedded in cultural memory, transformed into myth and poetry, woven into the fabric of human understanding about the natural world. Let us imagine, for a moment, what it was like to be an ancient observer. Picture yourself living 3,000 years ago in a small farming community somewhere along the eastern Mediterranean coast. Your life revolves around the growing season. If the rains fail, your crops fail, and hunger follows. You have no scientific instruments, no weather forecasts, no written almanacs, but you have the stars and you have the accumulated knowledge passed down from your parents and grandparents. Every clear night, you observe the sky. You notice which stars appear on the horizon just before sunrise, and you watch how this pattern changes throughout the year. You see how the first appearance of certain stars coincides with the arrival of rain, year after year after year. This knowledge becomes sacred. It becomes part of your stories, your songs, your religious practices. The stars are not merely distant lights, they are active participants in the cycle of seasons, in the continuation of life itself. The astronomical reality of the Hyades is equally fascinating, though in a different way than the myths suggest. The Hyades cluster is what astronomers call an open cluster, sometimes referred to as a galactic cluster. This term describes a relatively loose association of stars, all born from the same giant molecular cloud of gas and dust, all approximately the same age, all moving through space together as a group. Open clusters are contrasted with globular clusters, which are much more densely packed, spherical collections of hundreds of thousands or even millions of stars. The Hyades contains only a few hundred stars bound together by their mutual gravity and shared motion, spread across a region of space about 75 light-years in diameter. From Earth, the cluster appears to span about 5.5 degrees of sky, roughly equivalent to the width of 11 full moons placed side by side. At a distance of 153 light-years, the Hyades is actually the closest open star cluster to our solar system. This proximity makes it an object of tremendous scientific value. Astronomers have studied the Hyades intensively for more than a century because its nearness allows for precise measurements of stellar properties. The cluster has served as a fundamental calibration point for understanding stellar evolution, stellar atmospheres, and the relationship between a star's mass, temperature, and luminosity. When astronomers want to test theoretical models of how stars form, age, and die, they often turn to the Hyades because the cluster's stars are close enough that their individual characteristics can be measured with great accuracy. The age of the Hyades cluster has been determined, through various methods, to be approximately 625 million years old. This might sound ancient, and it is by human standards, but it represents young adulthood in stellar terms. Our own Sun, by comparison, is about 4.6 billion years old, more than 7 times older than the Hyades cluster. The stars of the Hyades formed together from a collapsing cloud of interstellar material during the period when Earth's oceans were just beginning to support complex multicellular life. Trilobites crawled across the seafloor beneath Earth's ancient waters, while the Hyades stars were igniting their nuclear furnaces for the first time. Since then, these stars have orbited the galactic center together, a stellar family maintaining its coherence across hundreds of millions of years and trillions upon trillions of miles. The cluster is currently moving through our region of the Milky Way galaxy on a trajectory that will eventually carry it away from Earth. In approximately 50 million years, the Hyades will have moved so far in their orbit around the galaxy that they will no longer be visible from Earth's night sky as a distinct cluster. But for now, for this brief cosmic moment that encompasses all of human history and much more, the Hyades shine in our sky just as they shone for our most distant ancestors. Before we delve deeper into the mythology and science of these stars, let us take a moment to visualize them more clearly. If you were to look at the Hyades through binoculars or a small telescope, you would see not just the 5 or 6 stars visible to the naked eye, but dozens more, scattered like diamond dust across the velvet darkness. The cluster's V-shape would become more apparent, and you might begin to understand why so many cultures saw meaningful patterns in this configuration. The brightest true members of the cluster are called Theta Tauri, Gamma Tauri, Delta Tauri, and Epsilon Tauri, along with several others designated by numbers in various astronomical catalogues. These stars range in color from blue-white to orange-red, depending on their temperature and stage of evolution. Some are larger and more luminous than our Sun, others are smaller and dimmer. The ancient Greek mythology surrounding the Hyades is rich with variations, but most versions agree on the fundamental narrative. The Hyades were nymphs, daughters of the Titan Atlas and the Oceanid Aethra, which made them sisters to the Pleiades, another famous star cluster that appears nearby in the constellation Taurus. Some sources say there were 5 Hyade sisters, others claim 7, 12, or even more. The names given to them include Faecula, Coronis, Clea, Phiao, Eudora, Ambrosia, Polyxo, and others, though these names vary significantly across different ancient texts. They were said to have been responsible for raising the infant god Dionysus, the god of wine, revelry, and transformation. As a reward for their nurturing care of this divine child, Zeus placed them in the heavens as stars. But there is another, sadder version of the story, one that emphasizes grief and consolation rather than reward. In this telling, the Hyades had a beloved brother named Hyades, a young hunter. One day, Hyades went out hunting and was killed by a wild animal. Some stories say a lion, others a serpent or a boar. When the sisters learned of their brother's death, they were consumed by grief. They wept so intensely and for so long that the gods took pity on them and transformed them into stars, ending their suffering by placing them beyond the reach of earthly sorrow. This version of the myth connects more directly to the association with rain, as the sisters' tears became the rains that fall when the cluster appears in the sky. The name Hyades itself may be related to the word for rain, creating a linguistic loop that binds the siblings together through language, mythology, and meteorology. There is something deeply moving about this myth when we contemplate it under the night sky. The ancient Greeks, in their wisdom, understood that the heavens were not merely physical objects, but also repositories of human emotion and experience. By placing the grieving sisters among the stars, the myth acknowledges the universality of loss, while also suggesting that sorrow can be transformed into something beautiful and enduring. Every time someone looks up and sees the Hyades, they are, in a sense, witnessing that grief, recognizing it, and yet also seeing how it has been transmuted into something that guides travelers, marks seasons, and inspires wonder. The stars become a memorial, a comfort, and a practical tool all at once. The connection between the Hyades and their brother Hyades is preserved not only in myth, but also in the constellation itself. Some ancient sources identified the star Aldebaran as representing Hyades, the brother, forever separated from his sisters but still appearing close to them in the sky. This interpretation gains a certain poignancy when we remember that Aldebaran is not actually part of the Hyades cluster, that it only appears to be associated with them due to a chance alignment. The separation is more profound than the ancient Greeks realized. Aldebaran stands apart not by a small distance, but by dozens of light years, a sister or brother lost not just to death, but to the fundamental structure of the universe itself. Roman culture inherited the Greek myths of the Hyades, but adapted them to suit Roman agricultural and religious practices. The Roman calendar was intimately tied to stellar observations, and the Hyades played a role in timing various festivals and agricultural activities. The poet Ovid, in his Fasti, a poetic calendar that describes Roman religious festivals throughout the year, mentions the Hyades multiple times in connection with seasonal changes and the activities appropriate to each season. Roman farmers watched for the morning rising of the Hyades in late spring as a signal to prepare for the grain harvest, and they noted the evening setting of the cluster as an indication that the hot, dry days of summer were approaching. The Roman natural philosopher Seneca, in his Natural Questions, discusses the Hyades in the context of meteorological phenomena. Seneca was interested in understanding the causes of natural events, winds, earthquakes, comets, and weather patterns, and he examined how the ancients used stellar observations to predict these events. Though Seneca himself was skeptical of the idea that stars directly caused weather changes, he acknowledged the observable correlation between the appearance of certain stars and the onset of seasonal patterns. This represents an important step in the evolution of human thought, the recognition that correlation does not necessarily imply causation, and the attempt to find natural explanations for phenomena that had previously been explained entirely through divine intervention or mystical influence. As we move through history, beyond the classical period of Greece and Rome, we find that the Hyades continue to capture human attention. Medieval European astronomy, heavily influenced by Islamic astronomy, which had preserved and expanded upon Greek astronomical knowledge during the early Middle Ages, included the Hyades in various star catalogues and astronomical treatises. The Persian astronomer Abd al-Rahman al-Sufi, working in the 10th century, included the Hyades in his Book of Fixed Stars, describing the cluster's appearance and position with careful detail. Al-Sufi's work would later be translated into Latin and become a key source for European astronomers during the Renaissance. During the Renaissance, as European astronomers began to challenge ancient astronomical models and develop new instruments for observation, the Hyades took on new significance. The invention of the telescope in the early 17th century revolutionized astronomy, allowing observers to see celestial objects with unprecedented clarity. When Galileo Galilei turned his telescope toward the Hyades in the early 1600s, he discovered that the cluster contained many more stars than were visible to the naked eye. This observation helped to confirm that the Milky Way itself was composed of countless individual stars, a revelation that expanded the known universe immensely. The great astronomer William Herschel, working in the late 18th and early 19th centuries, made systematic observations of star clusters, including the Hyades. Herschel was interested in understanding the structure and nature of these stellar groupings. Were they merely chance alignments of unrelated stars, or did they represent genuine physical associations? Through careful observation and measurement, Herschel began to suspect that clusters like the Hyades were indeed real physical groups, not just optical illusions. This insight would eventually lead to the modern understanding of stellar populations and galactic structure. By the 19th century, astronomers had developed techniques for measuring stellar positions with great precision. They discovered that the stars of the Hyades all shared a similar motion through space, a finding that confirmed the cluster's physical reality. All the member stars were moving in roughly the same direction at roughly the same speed, like a flock of birds flying in formation. This shared motion became a key piece of evidence that the Hyades stars were born together and remained gravitationally bound to one another. The cluster was not a random arrangement, but a family of stars with a common origin and shared destiny. The development of spectroscopy in the mid to late 19th century added another powerful tool to astronomical investigation. By analyzing the light from stars through a spectroscope, astronomers could determine a star's chemical composition, temperature, and radial velocity, how fast it was moving toward or away from Earth. When spectroscopic observations were applied to the Hyades, astronomers found that all the cluster members had similar chemical compositions, further evidence of their common birth from the same interstellar cloud. They also measured the radial velocities of the stars and found that these, too, were consistent with the stars moving together through space. One of the most important discoveries about the Hyades came through the study of proper motion, the apparent movement of stars across the sky over time. Because the Hyades cluster is relatively close to Earth, its stars show measurable proper motions over periods of decades. Astronomers noticed something remarkable. The proper motions of the Hyades stars were not random. When traced backward or forward in time, these motions converged toward a single point in the sky, called the convergent point. This phenomenon occurs because the cluster is moving away from us at an angle, and perspective makes all the stars appear to move toward the same vanishing point, just as parallel railroad tracks appear to converge in the distance. This convergent point method allowed astronomers to calculate the distance to the Hyades with great accuracy, and this distance measurement then served as a crucial rung on the cosmic distance ladder, helping astronomers determine the distances to more remote objects throughout the universe. The importance of the Hyades cluster to modern astronomy cannot be overstated. Because we can measure its distance so accurately, and because we can study its individual stars in such detail, the Hyades has become a fundamental calibration standard. Astronomers use the well-studied properties of Hyades stars to test and refine theoretical models of stellar structure and evolution. When astronomers develop a new theory about how stars of a certain mass and composition should behave, one of the first things they do is check whether their theory correctly predicts the observed properties of Hyades stars. If the theory fails this test, it must be revised. In the 20th century, observations of the Hyades expanded beyond visible light. Radio telescopes, infrared detectors, and eventually space-based observatories studying ultraviolet and X-ray emissions all turned their attention to the cluster. Each wavelength of light revealed different aspects of the star's nature. X-ray observations, for example, helped astronomers understand the magnetic activity and coronal heating processes in Hyades stars, particularly those similar to our Sun. Infrared observations revealed the presence of cooler, dimmer stars that were invisible to traditional optical telescopes, allowing astronomers to construct a more complete census of the cluster's population. The European Space Agency's Hipparcos satellite, launched in the early 1990s, made extremely precise measurements of stellar positions and parallaxes, the apparent shift in a star's position due to Earth's orbit around the Sun. These measurements allowed astronomers to determine the distances to Hyades stars with unprecedented accuracy, refining our understanding of the cluster's three-dimensional structure. More recently, the Gaia space mission, also operated by the European Space Agency, has measured the positions, distances, and motions of over 1 billion stars in our galaxy with extraordinary precision. The Gaia data has revolutionized our understanding of the Hyades, revealing details about the cluster's structure, rotation, and interaction with the gravitational field of the Milky Way that were previously impossible to discern. One of the surprising discoveries from the Gaia mission is that the Hyades cluster has two distinct tails of stars stretching across hundreds of light-years of space. These tails consist of stars that were once part of the cluster, but have been gradually stripped away by gravitational interactions with other structures in the galaxy. Over hundreds of millions of years, the cluster is slowly losing members, dissolving back into the general stellar population of the galaxy. This discovery provides a glimpse of the cluster's future. Eventually, perhaps a few hundred million years from now, the Hyades will have dispersed completely, its stars scattered across the galactic disk, no longer recognizable as a coherent group. But even then, those stars will carry with them the chemical signature of their common birth, and astronomers of the distant future may be able to identify them as siblings even though they will be separated by vast distances. This brings us to a profound realization about the nature of time and change in the universe. The Hyades cluster, which has seemed eternal and unchanging to countless generations of human observers, is actually a temporary structure, slowly dissolving as we watch. The myths that call the Hyades eternal sisters gain a certain irony in light of this knowledge, but perhaps they also gain a deeper truth. The stars are sisters, but even sisters cannot stay together forever. They drift apart, pulled by the inexorable forces of gravity and motion, each eventually going their separate way. Yet the memory of their connection remains, encoded in their physical properties, waiting to be discovered by those with the tools and knowledge to see it. Let us turn our attention now to the individual stars that make up the visible core of the Hyades cluster. Each of these stars has its own story, its own characteristics, its own place in the grand tapestry of cosmic evolution. While ancient observers saw the cluster as a unified whole, modern astronomers understand that each star is a unique world, a sphere of plasma held together by its own gravity, generating energy through nuclear fusion in its core, slowly transforming lighter elements into heavier ones. Evolving along a path determined by its initial mass and composition, the brightest true member of the Hyades, as seen from Earth, is Theta Tauri, also known by its Bayer designation and as Aldebaran when incorrectly grouped, though as we have noted, Aldebaran is actually a foreground star. Theta Tauri itself is actually a complex system of multiple stars. The primary component is a giant star, much larger and more luminous than our Sun, with a surface temperature of around 6,000 degrees Celsius. This star has evolved beyond the main sequence phase of stellar life, having exhausted the hydrogen fuel in its core and expanded to become what astronomers call a subgiant or giant star. In a few 100 million years, stars like this will continue to evolve, eventually shedding their outer layers and leaving behind a dense core called a white dwarf. Gamma Tauri, another prominent member of the cluster, is also a giant star, though somewhat cooler and redder than Theta Tauri. It shines with a warm, orange light that betrays its lower surface temperature, around 4,000 degrees Celsius. Stars like Gamma Tauri are in a particularly interesting phase of evolution. They have left the main sequence where they spent most of their lives steadily fusing hydrogen into helium in their cores. Now they are fusing helium into heavier elements like carbon and oxygen, a process that occurs at higher temperatures and produces more energy. This increased energy output causes the star's outer layers to expand dramatically, making the star much larger in radius even though its core is contracting. The result is a luminous giant star with a relatively cool surface temperature but enormous total energy output. Delta Tauri is another notable member, a triple star system where 3 stars orbit their common center of mass. The primary star is larger and hotter than our Sun, while its companions are smaller and cooler. These stars are locked in an intricate gravitational dance that will continue for millions of years, their orbits slowly changing due to tidal interactions and the influence of passing stars or gas clouds. Systems like this are common in the galaxy. Perhaps half of all stars exist in multiple star systems rather than as solitary objects like our Sun. Studying these systems helps astronomers understand how planets might form and survive in environments where multiple stars provide changing sources of light and gravitational influence. Epsilon Tauri is particularly interesting because it is one of the Hyades stars most similar to our own Sun. It has roughly the same mass, temperature, and luminosity as the Sun, making it what astronomers call a solar analog. By studying stars like Epsilon Tauri, which are at the same evolutionary stage as the Sun, but in a different environment, astronomers can learn more about solar physics, stellar atmospheres, and the potential for planetary systems around Sun-like stars. If Epsilon Tauri has planets, and if any of those planets orbit in the star's habitable zone where liquid water could exist on a planetary surface, then those planets might harbor conditions suitable for life. We don't know if such planets exist, but the question reminds us that every star we see is potentially a sun to its own family of worlds. Beyond these naked-eye stars, the Hyades contains hundreds of fainter members, red dwarfs that will burn their hydrogen fuel for trillions of years, living far longer than the current age of the universe, white dwarfs that represent the end state of stars like our Sun, dense remnants no longer generating energy through fusion, but slowly cooling over billions of years, and brown dwarfs, failed stars that never achieved the mass necessary to ignite hydrogen fusion in their cores, and instead slowly radiate away the heat left over from their formation. The Hyades cluster also contains what astronomers call blue stragglers, stars that appear younger and bluer than they should be given the cluster's age. These stars present a puzzle. If all the cluster members formed at the same time, why do some appear younger? The answer lies in stellar collisions and mass transfer. In a crowded stellar environment, stars occasionally collide and merge, creating a new star with more mass than either of the originals. Alternatively, in a close binary system, one star may transfer mass to its companion, rejuvenating the companion star and making it appear younger. Blue stragglers are the products of these unusual interactions, and their presence tells us about the complex gravitational dynamics at work within star clusters. As we explore the Hyades in ever greater detail, we begin to see it not as a simple collection of stars, but as a rich, dynamic system where stars are born, evolve, interact, and eventually disperse. Each star is a world unto itself, yet all are connected through their shared history and ongoing gravitational interaction. This perspective mirrors something essential about human experience. We too are individuals with our own unique characteristics, yet we are also part of larger groups, families, communities, civilizations, and these connections shape who we are and how we move through the world. The ancient cultures that observed the Hyades understood this intuitively, even if they expressed it through mythology rather than physics. The story of the Hyade sisters, bound together by love and grief, transformed into stars that move through the heavens as a group, captures a truth about connection and separation, continuity and change. When the ancient Greeks looked at these stars and saw sisters, they were recognizing a pattern that modern astronomy has confirmed. These are indeed related objects, a family born together, moving together, eventually to be separated by time and distance, but forever linked by their common origin. Now let us expand our perspective and consider how other cultures beyond the Mediterranean world understood and incorporated these stars into their cosmologies. The universality of human stargazing means that virtually every culture with a clear night sky developed its own names, stories, and practical uses for the bright stars and obvious patterns visible overhead. The Hyades, being both bright and distinctive in shape, attracted attention across the globe. In ancient China, astronomy was a matter of state importance. The emperor's legitimacy was thought to depend partly on his ability to maintain harmony between heaven and earth, and this required careful observation and interpretation of celestial phenomena. Chinese astronomers divided the sky into different regions and asterisms, creating a system quite different from the Greek constellation figures that dominate modern Western astronomy. The stars we call the Hyades were part of a lunar mansion called Bai, which translates as net or rabbit net, said to represent a net used for hunting. This asterism was associated with the element of water and with rainy weather, paralleling the Mediterranean association between these stars and rain. Chinese astronomical records, preserved in historical texts dating back thousands of years, mention the Bai asterism in connection with seasonal rains and agricultural timing. The appearance of these stars at certain times of year signaled to farmers when to plant rice, when to prepare irrigation systems, and when to expect the monsoon rains that were crucial to agriculture across East Asia. The precision and continuity of Chinese astronomical observation is remarkable. Records exist that document celestial events, including the positions and behaviors of stars, comets, and planets, across more than 2,000 years. These records have proven valuable to modern astronomers, who can use them to study long-term changes in the heavens and to date historical events. In India, Vedic astronomy incorporated the stars into a system of lunar mansions called nakshatras, used for both astronomical calculation and astrological interpretation. The nakshatra corresponding to the Hyades region was called Rohini, often represented as a red deer or cart. Rohini was considered especially auspicious in Vedic astrology, associated with fertility, growth, and prosperity. The timing of religious festivals and agricultural activities was often determined by the moon's position relative to these nakshatras, and Rohini held a place of particular importance in this system. Indigenous cultures of the Pacific Islands developed extraordinary navigational systems based on careful observation of the stars, ocean swells, winds, and bird behavior. Polynesian navigators could traverse thousands of miles of open ocean without instruments, using only their knowledge of natural patterns. The stars of the Hyades were part of this navigational toolkit. Different island groups had different names for these stars, and the cluster's rising and setting times helped navigators determine their latitude and the appropriate sailing season for long voyages. The precision of this knowledge is staggering. Navigators could determine their position within a few miles using only the information available to their senses, demonstrating that sophisticated astronomy requires not telescopes or mathematics, but only careful attention and accumulated experience. Among various Native American cultures, the Hyades and nearby Pleiades were often grouped together in myths and practical astronomy. Some Plains tribes told stories of these star groups as different bands of people or different groups of animals, often in narratives that explained seasonal changes or taught moral lessons. The Lakota people told of a race between groups of stars, while other tribes incorporated these stars into creation myths or stories about culture heroes. The appearance of these stars in the dawn or evening sky helped guide the timing of buffalo hunts, seasonal migrations, and religious ceremonies. In Australian Aboriginal astronomy, which represents one of the oldest continuous astronomical traditions in human history, the stars we call Hyades were incorporated into complex stories that encoded practical knowledge about seasonal changes, animal behavior, and navigation. Different Aboriginal language groups had different names and stories for these stars, but many incorporated them into larger narratives about ancestral beings whose actions during the dreamtime shaped both the land and the sky. These stories served multiple purposes. They were entertainment, moral instruction, practical guides to seasonal changes, and maps of both the terrain and the heavens. The sophistication of Aboriginal astronomy is increasingly recognized by scholars, who have discovered that these oral traditions contain detailed knowledge of stellar positions, planetary motion, and even phenomena like variable stars and eclipsing binaries. This brief survey of cultural interpretations of the Hyades demonstrates something profound about human cognition and culture. Despite enormous differences in language, geography, technology, and social organization, humans across the world independently developed systems for observing and interpreting the night sky. We all looked up at the darkness and saw patterns. We all noticed that these patterns changed throughout the year and that these changes correlated with seasonal transformations on Earth. We all created stories to encode and transmit this knowledge across generations. And we all, in our different ways, felt a sense of connection to the stars, a feeling that the heavens were not separate from our lives but intimately involved in them. Modern astronomy has, in some ways, disenchanted the stars. We know now that they do not cause rain or influence human destiny. We understand them as balls of hot plasma, powered by nuclear fusion, following predictable paths determined by gravity and motion. The stars are indifferent to human concerns. They shine and die according to the laws of physics, without thought or intention. Yet this knowledge brings its own form of wonder, one arguably deeper than the old mythological understanding. The stars are not merely lamps hung in the sky by gods. They are the forges where chemical elements are created, the engines that make complex chemistry and eventually life possible. The atoms in your body were literally formed inside stars that lived and died long before our solar system existed. We are, as the astronomer Carl Sagan famously said, made of star stuff. This connection between human and cosmos is more intimate and more astonishing than any myth of divine creation. The Hyades cluster, in this context, becomes more than just a group of stars or a subject of ancient myth. It becomes a laboratory for understanding stellar evolution, a milestone in humanity's growing comprehension of cosmic structure, and a reminder of our place in the vast architecture of space and time. When we look at the Hyades, we are looking backward through both space and time. The light we see tonight left those stars more than a century and a half ago, when Abraham Lincoln was President of the United States, when the American Civil War was being fought, when Charles Darwin was still alive, and his theory of evolution was still controversial. The photons entering your eyes tonight began their journey across the void before your great-great-grandparents were born. This perspective on light travel time becomes even more vertiginous when we consider that different stars in the cluster are at slightly different distances from Earth. The Hyades cluster is approximately 75 light-years in diameter, which means that light from the nearest members reaches us about 75 years before light from the most distant members. When we look at the cluster, we are not seeing it as it exists in a single moment, but as it existed across a span of more than a century, with each star frozen in a different instant of cosmic time. This strange relationship between light, distance, and time is fundamental to astronomy. We can never observe the universe as it is now. We can only see it as it was, and the farther we look, the further back in time we peer. The Hyades cluster orbits the center of our Milky Way galaxy just as our Sun does, but the cluster follows a different path through the galaxy than our solar system does. Imagine the Milky Way as a vast disk of stars, gas, and dust, spinning slowly around a central bulge where stars are more densely packed and where a supermassive black hole resides. Our Sun is located about halfway out from the galactic center to the edge of the disk, in a relatively sparse region between major spiral arms. The Sun takes approximately 230 million years to complete one orbit around the galactic center, a period sometimes called a galactic year or a cosmic year. The Hyades cluster is also orbiting the galactic center, but because it is at a slightly different distance and has a different velocity, its orbital period is slightly different from the Sun's. What makes this orbital motion particularly interesting is that the Hyades cluster is currently moving through our region of the galaxy, approaching the general area where our Sun resides, though not on a collision course with us. The cluster's motion through space has been precisely measured thanks to modern astrometry. Astronomers have determined that the cluster is moving at approximately 45 kilometers per second relative to the Sun. To put this in perspective, if you could somehow stand still in space and watch the Hyades cluster move past you, it would cross a distance equal to the width of Earth in about 5 minutes. This is extraordinarily fast by terrestrial standards, yet it is typical for stellar motions within our galaxy. The stars are not stationary points of light, but bullets fired from ancient guns, all flying through the void at tremendous speeds, held in their courses by the massive gravitational field of the galaxy itself. As the Hyades cluster moves through the galaxy, it interacts gravitationally with other structures. When the cluster passes near a giant molecular cloud, regions of space where gas and dust are densely concentrated and where new stars are being born, the cloud's gravity can tug on the cluster's stars, slightly altering their velocities and orbits. Over millions of years, these small perturbations accumulate. Stars on the outer edges of the cluster, where the gravitational binding is weakest, gradually drift away. This process, called evaporation, slowly reduces the cluster's population. Eventually, the cluster will disperse entirely, its stars scattered across the galaxy. their common origin detectable only through detailed chemical analysis and motion studies. This raises a fascinating question. How many of the stars we see in our night sky might have been born in clusters like the Hyades but have since dispersed? Our Sun itself might have been part of a star cluster 4.5 billion years ago. If so, the Sun's siblings are now scattered throughout the galaxy, indistinguishable from the general stellar population unless we can identify them through their chemical signatures and orbital characteristics. Some astronomers are actively searching for the Sun's lost siblings, using data from the Gaia space mission to trace stellar orbits backward in time and identify stars that might have been born in the same stellar nursery as our Sun. If such siblings can be found, they would be of immense scientific interest. Stars born in the same cloud have nearly identical chemical compositions, and studying the Sun's siblings could help astronomers understand the conditions in the solar nebula from which Earth and the other planets formed. The Hyades cluster provides a glimpse of what the Sun's birth cluster might have looked like, though the Sun's original cluster was probably somewhat more populous. When the Sun formed, it was likely surrounded by hundreds or thousands of sibling stars, all born from the same collapsing cloud of gas and dust. Some of these stars might have had planetary systems of their own. For a few million years, these stars would have remained relatively close together, perhaps within a few light-years of each other. During this time, the young stars' planetary systems would have been vulnerable to gravitational interactions. Close encounters between star systems could have disrupted planetary orbits, ejected planets into interstellar space, or even caused exchanges where one star captured a planet from another. Some astronomers have speculated that the outer regions of our solar system, the realm of comets and distant icy bodies, might contain objects that originally formed around the Sun's sibling stars but were captured by the Sun's gravity during the cluster phase. After a few million years, the Sun's birth cluster would have begun to disperse. The most massive stars in the cluster would have evolved rapidly, living their brief, brilliant lives and exploding as supernova. These explosions would have injected energy and heavy elements into the surrounding space, possibly triggering the formation of new stars in nearby clouds. The less massive stars, like the Sun, continued their sedate lives, slowly drifting apart as galactic tides and gravitational encounters disrupted the cluster's coherence. By the time Earth had cooled enough to support liquid water on its surface, about 4 billion years ago, the Sun's siblings would have been scattered across a region hundreds of light-years wide. Today, they are dispersed throughout the galaxy, and we don't know which stars they are. This narrative of stellar birth, evolution, and dispersal is written in the structure and composition of the Hyades cluster. By studying the Hyades, astronomers learn to read this story in other clusters and gradually piece together a comprehensive understanding of how stars form and evolve throughout our galaxy. Each star cluster is like a chapter in a vast book, and the Hyades, being so close and so well studied, is one of the most clearly written chapters we have. The chemical composition of Hyades stars has been studied in extraordinary detail. Astronomers use spectroscopy to analyze the light from these stars, looking for the distinctive patterns created when light passes through a star's atmosphere. Different chemical elements absorb and emit light at specific wavelengths, creating a unique spectral fingerprint. By analyzing these spectral lines, astronomers can determine which elements are present in a star's atmosphere and in what proportions. This technique, pioneered in the 19th century, has revealed that the Hyades stars all share a very similar chemical composition, another confirmation of their common origin. The Hyades stars are slightly enriched in heavy elements compared to the Sun. Astronomers measure this enrichment using a quantity called metallicity, which confusingly refers to all elements heavier than helium, not just actual metals. The Hyades stars have a metallicity about 1.3 to 1.4 times solar, meaning they contain about 30 to 40% more heavy elements than the Sun does. This higher metallicity tells us something about the history of star formation in our region of the galaxy. The Hyades formed from a cloud of gas that had been enriched by previous generations of stars that lived, died, and expelled their processed material into space. The more generations of stars that have lived and died in a region, the more enriched the interstellar gas becomes with heavy elements. This process of cosmic chemical enrichment is one of the most important concepts in modern astronomy. When the universe began 13.8 billion years ago in the Big Bang, it contained only the lightest elements, hydrogen, helium, and trace amounts of lithium. Every element heavier than lithium has been created inside stars through nuclear fusion or in supernova explosions when massive stars die. Carbon, nitrogen, oxygen, iron, gold, uranium, all the elements that make up planets and people were forged in stellar furnaces. When stars die, they return this processed material to space, where it can be incorporated into new generations of stars and planets. This means that the heavy elements in your body were created inside stars that died before the sun was born. You are, quite literally, made from the ashes of dead stars. The Hyades stars, with their enhanced metallicity, formed from material that had been through multiple cycles of stellar processing. This also means that if any of these stars have planetary systems, those planets would have formed from material richer in heavy elements than the planets in our solar system. Would such planets be fundamentally different from Earth? Would they be more likely or less likely to harbor life? These questions remain open, though astronomers are beginning to explore them through observations of exoplanets, planets orbiting stars other than the Sun. The search for exoplanets around Hyades stars has been ongoing for several decades, though finding planets in clusters presents special challenges. The gravitational interactions between stars in a cluster can make planetary orbits unstable, and close encounters between stars might strip planets from their parent stars entirely. Nevertheless, a few exoplanet candidates have been detected around Hyades stars. These detections are still being confirmed and studied, but they raise tantalizing possibilities. If the Hyades does harbor planets, especially planets in the habitable zones of their stars, then those worlds would have existed for 625 million years, time enough for complex life to evolve if conditions were favorable. Imagine for a moment that a habitable planet orbits one of the Hyades stars. What would the sky look like from that world? An observer on such a planet would see the other Hyades stars spread across their sky, some appearing much brighter than any star we see from Earth because of their proximity. The night sky would be dramatically different from Earth's, with dozens of bright stars forming unfamiliar patterns. If intelligent life had evolved on such a planet, how would their astronomy have developed? Would they have recognized more quickly that stars form in groups? Would they have found it easier to measure stellar distances because so many bright stars were nearby? Would their mythology and culture have developed differently because their night sky was so much richer in bright stars? These speculations remind us that Earth occupies a particular place in the galaxy, and our view of the universe is shaped by that location. We see the Hyades as a compact cluster in our sky, but from within the cluster, the stars would be scattered across the celestial sphere. Our perspective is not the only possible perspective, and our human experience of the cosmos is not the only possible experience. This is a valuable lesson in humility and imagination. The universe does not arrange itself for our convenience or comprehension. We must work to understand it, and part of that work involves recognizing the limitations and peculiarities of our own viewpoint. The gravitational dynamics within the Hyades cluster are complex and fascinating. Each star in the cluster exerts a gravitational pull on every other star, creating a constantly shifting web of forces. The cluster as a whole has a gravitational field that tends to keep its members together, but this field is not uniform. Stars near the center of the cluster experience stronger gravitational binding than stars on the outskirts. Additionally, the cluster's motion through the galaxy exposes it to external gravitational forces, tidal forces from the Milky Way's overall gravitational field, and discrete encounters with giant molecular clouds, other star clusters, or dense spiral arms. Astronomers use computer simulations to model these gravitational interactions and predict the cluster's future evolution. These simulations, called n-body simulations, calculate the gravitational force between every pair of stars and update each star's position and velocity in tiny time steps, gradually advancing the simulation forward through cosmic time. Such simulations have revealed that the Hyades is currently in a phase of gradual dissolution. The cluster is losing mass, primarily from its outer regions, and this mass loss will accelerate over the next few hundred million years. Eventually, the cluster will reach a point where the remaining stars are no longer gravitationally bound as a group, and at that point, the cluster effectively ceases to exist, even though its former members continue to orbit the galaxy as individual stars. This fate, gradual dissolution and dispersal, is the common destiny of most open star clusters. They are not permanent structures but temporary gatherings that form, persist for a cosmically brief time, and then disperse. Globular clusters, by contrast, are much more tightly bound and can survive for many billions of years, sometimes for the entire age of the universe. The difference lies in the strength of gravitational binding and the environment in which the clusters exist. Globular clusters are typically found in the halo of the galaxy, far from the disk where most stars and gas reside, and thus they experience fewer disruptive encounters. Open clusters like the Hyades form in the galactic disk, where they are subject to frequent gravitational perturbations that gradually tear them apart. Yet even this dissolution has a kind of beauty to it when viewed from a cosmic perspective. The dispersal of a star cluster returns stellar mass to the general galactic population, and some of those stars may eventually participate in the formation of new clusters or planetary systems. The galaxy is not a static structure, but a vast recycling system where matter and energy flow through different forms. Gas clouds collapse to form stars. Stars live and die, returning processed material to space. That material mixes with fresh hydrogen from intergalactic space. New clouds form and new stars are born. The Hyades cluster is one eddy in this great cosmic river, a temporary concentration that will eventually dissolve back into the flow. This perspective on cosmic recycling and transformation connects back to the ancient myths in unexpected ways. The story of the Hyade sisters, transformed into stars through grief or as a reward for service, can be read as an early intuition about transformation and impermanence. The ancient Greeks understood, at least poetically, that change is fundamental to existence, that nothing remains the same forever. Their myths often dealt with transformation, people becoming stars, gods changing their forms, mortals ascending to immortality or immortals descending to mortality. These stories reflected a deep awareness that the universe is dynamic, that stability is temporary, and that everything participates in cycles of change. Modern astronomy confirms this ancient intuition, but extends it to scales unimaginable to the ancients. Stars are born, live, and die. Galaxies collide and merge. The universe itself is expanding, carrying distant galaxies ever farther apart. The cosmic background radiation light left over from the Big Bang is gradually redshifting as space expands, its photons stretching to longer and longer wavelengths. Trillions of years in the future, when all the stars have exhausted their fuel and died, the universe will be a cold, dark place filled with black holes, neutron stars, and the fading embers of white dwarfs. Even these remnants will eventually decay, though on timescales so long they defy human comprehension. The universe, like the Hyade sisters, is not eternal. It has a beginning and it will have an end, though the end is unimaginably distant. Yet knowing this does not diminish the wonder of existence. If anything, it enhances it. The fact that we live in an era when stars shine, when galaxies dance, when planets harbor life and consciousness, this is not to be taken for granted. It is a cosmic gift, a brief window of richness and complexity between an ancient beginning and an unimaginably distant end. The Hyade stars have been shining for 625 million years, and they will continue to shine for hundreds of millions more. In that span of time, they have witnessed the evolution of complex life on Earth, from primitive marine organisms to the emergence of consciousness and technology. They shone when dinosaurs walked the Earth, and they will shine long after our species has either vanished or transformed into something we cannot now imagine. This leads us to contemplate one of the most profound questions raised by astronomy. Are we alone? Does life exist elsewhere in the universe? If so, how common is it, and has it ever achieved the complexity necessary for consciousness and civilization? The Hyades cluster, with its several hundred stars, represents several hundred opportunities for planetary systems and potentially for life. The conditions for life as we understand it, liquid water, stable energy input, the presence of complex chemistry, could exist on planets orbiting Hyades stars. If life has arisen in the cluster, it would have had 625 million years to evolve. On Earth, 625 million years ago, life was just beginning to experiment with complex multicellular forms. The first animals with hard shells, the creatures whose fossils mark the Cambrian explosion, were just appearing in Earth's oceans. If a similar timeline unfolded on a planet in the Hyades, that world might now be teeming with complex life, perhaps even intelligent life. If such a civilization existed in the Hyades, would we be able to detect it? Modern searches for extraterrestrial intelligence scan the skies for artificial radio signals or optical pulses that might indicate the presence of technology. The Hyades, being relatively close, would be an excellent target for such searches, and astronomers have indeed pointed radio telescopes at the cluster on several occasions. So far, no definitive artificial signals have been detected, but this proves little. We don't know what forms alien technology might take, or whether advanced civilizations would use radio communications in ways we could detect. An alien civilization might use technologies we haven't imagined, or they might communicate using methods that appear entirely natural to our instruments. The absence of detected signals does not mean the absence of life or intelligence. It means only that we haven't found clear evidence yet. The question of extraterrestrial life touches on deep philosophical and emotional territory. For most of human history, we believed we were unique, that Earth was the center of creation, that human beings held a special place in the cosmic order. Modern astronomy has systematically dismantled this belief. Earth is not the center of the solar system, the Sun is. The Sun is not the center of the galaxy. It is one star among hundreds of billions, orbiting in an obscure region far from the galactic core. Our galaxy is not the center of the universe. It is one galaxy among trillions in the observable universe. Each of these revelations has been humbling, forcing us to recognize that our position is not special, that the universe does not revolve around us. And yet, we are special in at least one way: we are aware. We are conscious beings capable of contemplating the universe, of asking questions about our origins and our place in the cosmic story. We build telescopes and spacecraft, write equations and poetry, create myths and scientific theories. We are, as far as we know, the universe's way of knowing itself. This capacity for understanding and wonder is precious precisely because we don't know how rare it is. If consciousness is common in the universe, then we are part of a grand cosmic community, potentially separated by vast distances, but united by the shared experience of being awake in the universe. If consciousness is rare or unique to Earth, then we bear a profound responsibility. We are the universe's only witnesses, the only minds capable of comprehending the billions of years of cosmic evolution that produced us. The Hyades stars shine on, indifferent to these questions as they have shone through the ages. They do not know they are being observed, do not care about the myths humans have woven around them, do not notice the telescopes pointed in their direction. They simply exist, fusing hydrogen into helium, radiating energy into space, slowly evolving along paths determined by physics. And yet, through us, through human consciousness and curiosity, these stars become more than mere objects. They become subjects of study, sources of wonder, anchors for stories that help us make sense of our existence. This transformation of cosmic objects into cultural meaning is one of humanity's defining characteristics. We cannot help but find patterns, tell stories, create connections between the external world and our internal experience. The Hyades, as physical objects, are collections of plasma undergoing nuclear fusion. The Hyades, as cultural objects, are sisters mourning their brother, rain bringers marking seasonal changes, navigational aids for ocean voyages, mythological figures embodying timeless themes of loss and transformation. Both descriptions are true, but they belong to different realms of truth. one to the realm of physical facts, the other to the realm of human meaning, modern culture often treats these realms as opposed or mutually exclusive. Science, we are told, deals with facts, art and mythology deal with feelings and stories. But this division is artificial. Science is itself a story about how we have come to understand the physical universe through observation, measurement, and reasoning. It is a story that grows more detailed and comprehensive with each generation, but it remains a human creation, limited by our perspectives and our cognitive capacities. Similarly, myths are not merely fictions or falsehoods, they are condensed expressions of human experience, vehicles for transmitting cultural knowledge, and frameworks for making sense of existence. The myth of the Hyades sisters is not scientifically accurate, but it is psychologically true. It captures something real about grief, about familial bonds, about the human need to find meaning in the patterns we observe around us. Perhaps the most mature relationship we can have with the cosmos is one that honors both scientific understanding and mythological meaning, that recognizes that these different ways of knowing complement rather than contradict each other. We can understand the Hyades as an open star cluster 153 light-years distant, formed 625 million years ago from a collapsing molecular cloud, slowly dispersing due to gravitational interactions with the galaxy. And we can simultaneously appreciate the Hyades as the weeping sisters, as rain bringers, as navigational guides, as symbols of transformation and transcendence. Both perspectives enrich our experience of these stars. As we move toward the conclusion of our journey through the Hyades story, let us return once more to the experience of observation. Imagine yourself standing outside on a clear, dark night, far from city lights. The stars crowd the sky from horizon to horizon, so many that they almost blur together. The Milky Way stretches overhead like a river of light, dividing the darkness. You locate the constellation Taurus, tracing the pattern slowly with your eyes. There is Aldebaran, glowing red-orange, seemingly embedded in a V-shaped group of fainter stars. You know now that this alignment is coincidental, that Aldebaran is much closer than the others, but from your perspective on Earth, they appear unified. You can see 5 or 6 stars in the cluster with your naked eye, perhaps more if your vision is acute and the sky is particularly dark. Raise binoculars to your eyes and the scene transforms. Dozens of stars suddenly become visible where before you saw only a handful. The V-shape becomes more defined, more obvious. The stars show subtle variations in color, some bluish-white, others yellow or orange, each hue revealing that star's temperature and evolutionary state. If you have a telescope, even a small one, the view becomes richer still. Stars that appeared single split into pairs or even triple systems. Faint stars emerge from the darkness, stars too dim for binoculars but easily visible through a telescope. The cluster becomes a jewel box, a collection of stellar gemstones scattered across black velvet. And if you could somehow perceive beyond visible light, if your eyes could see infrared radiation or ultraviolet light or X-rays, the cluster would reveal even more of its secrets. In infrared, you might see cool dust clouds or warm debris disks around stars. In ultraviolet, the hottest stars would blaze brightly while cooler stars faded. In X-rays, you would see the coronae of active stars, regions of superheated plasma held in place by powerful magnetic fields. Each wavelength of light reveals a different aspect of reality, a different facet of the cosmic story. This multispectral understanding of the universe is a relatively recent development in human history. For most of our time on Earth, we could observe only visible light, the narrow range of electromagnetic radiation to which our eyes are sensitive. The development of instruments that could detect other wavelengths, radio waves, microwaves, infrared, ultraviolet, X-rays, gamma rays, opened entirely new windows on the universe. We discovered that the cosmos is far stranger and more complex than visible light observations alone could reveal. Pulsars, quasars, gamma-ray bursts, the cosmic microwave background, all these phenomena were invisible to optical telescopes and became known only through observations at other wavelengths. The Hyades, observed across the full electromagnetic spectrum, becomes a laboratory for studying stellar physics in extraordinary detail. Radio observations reveal stellar winds and magnetic activity. Infrared observations penetrate dust and reveal cooler structures. Ultraviolet and X-ray observations probe the hot, energetic processes occurring in stellar atmospheres and coronae. By combining observations at all wavelengths, astronomers construct a comprehensive picture of what stars are and how they behave. This comprehensive understanding would have been impossible if we had remained limited to visible light alone. There is a lesson here about perspective and knowledge. What we can observe depends on our tools and our vantage point. Different perspectives reveal different truths. No single viewpoint captures everything, all are partial. The ancient observers who saw the Hyades as rain-bringers were not wrong. They were seeing one aspect of a complex truth. They noticed a genuine correlation between the cluster's position and seasonal weather patterns, and they encoded this practical knowledge in memorable mythological stories. Modern astronomers who see the Hyades as a dissolving open star cluster are also not wrong. They are seeing a different aspect of the same reality, revealed by different tools and different questions. Both perspectives are valuable. Both contribute to human understanding. This realization suggests a kind of humility and openness that serves us well, not only in science, but in all domains of human experience. We should hold our understandings lightly, recognizing that they are always incomplete, always subject to revision as new information and new perspectives emerge. The history of astronomy is a history of surprises, of confident beliefs overturned by new observations. The Earth is not the center of the universe. The Milky Way is not the entire universe. Space is not static, it expands. Stars are not eternal, they evolve and die. Black holes, once thought to be purely theoretical curiosities, have been photographed. Gravitational waves, predicted by Einstein but thought to be undetectable, have been measured. Each of these discoveries required scientists to revise their understanding, to let go of cherished beliefs, to embrace a more complex and surprising reality. The Hyades invite us to practice this same openness. What do we think we know about these stars? What might future observations reveal that will surprise us? How might our understanding continue to evolve as new instruments come online, as new theoretical frameworks are developed, as new questions are asked? The James Webb Space Telescope, launched in late 2021, is already transforming our understanding of the early universe, of exoplanet atmospheres, of star formation. What might it reveal about the Hyades? The future holds answers we cannot yet imagine, questions we have not yet thought to ask. And yet, for all our sophisticated understanding, there remains something fundamentally mysterious about the act of looking at stars. When you stand beneath the night sky and gaze upward, you are participating in an experience that connects you to every human being who has ever lived. Your ancient ancestors looked at these same stars, or at least at stars in these same positions, since the individual stars themselves have moved somewhat over the millennia due to their proper motions. Those ancient observers felt the same sense of wonder, the same questions about their place in the cosmos, the same desire to find meaning and pattern in the darkness overhead. This continuity of experience across time is profoundly moving when you allow yourself to feel it. The Hyades stars that you see tonight are the same stars that shepherds watched in ancient Mesopotamia, that sailors used to navigate the Mediterranean, that Chinese astronomers recorded in their careful chronicles, that Polynesian navigators followed across the Pacific. These stars have been witnesses to all of human history. They shone during the rise and fall of civilizations, during wars and peace, during moments of great tragedy and great triumph. They were there when the first cities were built, when writing was invented, when humans first learned to sail ships and forge iron and build cathedrals and split atoms. They will be there long after our current civilization has transformed into something else or vanished entirely. This perspective, sometimes called the cosmic perspective, can be both humbling and liberating. Humbling because it reveals how small we are, how brief our individual lives, how recent our entire species in the grand sweep of cosmic time. Liberating because it can free us from excessive concern with trivial matters, from the illusion that our personal dramas are of cosmic importance. The universe does not care about our anxieties, our ambitions, our successes or failures. This indifference is not cruel, it simply is. And in recognizing it, we can perhaps find a certain peace, a sense of proportion, an ability to take ourselves less seriously while still taking seriously the things that truly matter. Love, beauty, knowledge, kindness. The creation of meaning in a universe that offers no intrinsic meaning except what we create for ourselves. The Hyades in this sense become teachers. They teach us about time, deep time, cosmic time, time scales so vast they make human history seem like a single heartbeat. They teach us about change, slow, inexorable change that nevertheless transforms everything given sufficient duration. They teach us about connection, how separate objects can be bound together by invisible forces, how shared origins leave lasting signatures, how even in the vast emptiness of space, nothing is truly isolated. They teach us about impermanence, how even structures that seem eternal are temporary, dissolving eventually back into the cosmic medium from which they came. These lessons are not comfortable. They challenge our intuitions, our desire for permanence and significance, but they are also honest. They reflect the universe as it actually is, not as we might wish it to be. And there is a strange beauty in this honesty, an austere elegance in the laws of physics that govern everything from the smallest subatomic particle to the largest galaxy clusters. The universe is not designed for our comfort, but it is comprehensible to our minds, at least partially. We can study it, learn its patterns, predict its behavior. This comprehensibility is perhaps the greatest mystery of all. Why should the universe be mathematically describable? Why should the human mind, evolved to help our ancestors survive on the African savanna, be capable of understanding quantum mechanics and general relativity and stellar evolution? Some scientists and philosophers have pondered this question deeply. Perhaps the universe is comprehensible because comprehensibility is a prerequisite for the existence of observers. Only in a universe with stable, predictable laws could complex structures like stars, planets, and living beings arise. And only living beings that could understand those laws, at least partially, would survive and reproduce. We are capable of understanding the universe precisely because we evolved in a universe that could be understood. This anthropic reasoning is controversial and not entirely satisfying, but it points toward a deep connection between the structure of the cosmos and the structure of consciousness. The Hyades, glittering in the darkness of Taurus, know nothing of these philosophical speculations. They continue their patient stellar lives, fusing elements, radiating energy, slowly moving through the galaxy on their predetermined paths. Each star is a furnace, converting matter into energy according to Einstein's famous equation, E equals mc squared. A tiny amount of mass, multiplied by the speed of light squared, produces an enormous amount of energy. In the core of each Hyades star, 4 hydrogen nuclei fuse together to form one helium nucleus. The mass of the helium nucleus is slightly less than the combined mass of the 4 hydrogen nuclei that created it. This missing mass has been converted into energy, the energy that makes the star shine, that travels across space for 153 years, that eventually enters your eye and allows you to see the star. This process of nuclear fusion is the reason stars shine, the reason the universe is not cold and dark, the reason planets like Earth can be warm enough to support liquid water and life. Without fusion, the universe would be a very different place, still filled with matter perhaps, but without the sustained energy sources necessary for complexity and evolution. Fusion is also the process that creates heavier elements from lighter ones. Inside stellar cores, hydrogen becomes helium. In more massive stars, as they age and their cores contract and heat up, helium fuses into carbon and oxygen. Then carbon and oxygen fuse into even heavier elements like neon, magnesium, silicon, and iron. When massive stars explode as supernova, the intense energies involved create the heaviest elements of all, including gold, platinum, and uranium. The Hyades stars are currently in various stages of this fusion process. The most massive members of the cluster, those that formed with several times the Sun's mass, have already evolved off what astronomers call the main sequence, the stable, long-lived phase where stars spend most of their lives fusing hydrogen in their cores. These massive stars have become giants or subgiants, now fusing helium into heavier elements. The less massive members, including stars similar to the Sun and smaller red dwarfs, are still on the main sequence, steadily fusing hydrogen and will continue to do so for millions or billions of years more. This spread of evolutionary stages within a single cluster, all the same age, allows astronomers to study stellar evolution in action. By observing stars of different masses at a single point in time, astronomers can construct a picture of how stars change throughout their lives. This technique, sometimes called the method of stellar populations, has been fundamental to developing our modern understanding of stellar evolution. It works because more massive stars evolve more rapidly than less massive ones. A star 10 times the Sun's mass might live only a few million years, while a star 1/10 the Sun's mass will burn its hydrogen for trillions of years. By looking at a cluster like the Hyades, we can see stars at many different points along their evolutionary paths, allowing us to piece together the full story of stellar life cycles. The future evolution of the Hyades is predictable, at least in general terms. The cluster will continue to lose mass as stars evaporate from its outer regions. The most massive remaining stars will continue their evolution, eventually exhausting their nuclear fuel and dying as white dwarfs, or possibly as supernova if any are massive enough. The less massive stars will continue their patient hydrogen fusion for hundreds of millions of years more. Eventually, perhaps 500 million years from now, the cluster will have dispersed completely, its former members scattered across hundreds or thousands of light-years of space. Astronomers of the distant future might still be able to identify these stars as former Hyades members by analyzing their chemical compositions and orbital trajectories, but the cluster as a visible entity will have ceased to exist. This dissolution might seem sad, the end of a family that has remained together for more than 500 million years, but it is also natural, inevitable, part of the cycle of cosmic structure formation and destruction that governs the universe. Nothing lasts forever. Stars are born, clusters form, galaxies collide, and eventually, on timescales almost incomprehensible, even the protons and neutrons that make up atomic nuclei may decay into lighter particles. The universe tends toward disorder, toward entropy, toward a state of maximum randomness. This is the second law of thermodynamics, one of the most fundamental principles in physics. And yet, within this general tendency toward disorder, temporary islands of order and complexity can emerge. Stars are such islands, planets are such islands, living beings are such islands. We are temporary structures of exquisite complexity, arising briefly in the flow of time, persisting for a while, and then dissolving back into simpler forms. The recognition of this impermanence need not lead to despair. Instead, it can heighten our appreciation for the precious, temporary gift of existence. The Hyades stars will not shine forever, and neither will we live forever, but right now, in this moment, both they and we exist. The light from those stars has traveled across the void for more than a century to reach us tonight. In receiving that light, in processing it through our visual systems, in thinking about what it means and where it came from, we are engaging in a kind of cosmic conversation. The stars speak to us through their light, and we respond through our understanding and wonder. This conversation between humanity and the cosmos has been ongoing for as long as our species has existed. Our earliest ancestors, huddling around fires on the African savanna, looked up at the stars and wondered what they were. They created stories to explain the lights in the sky, stories that bound together their observations of nature with their understanding of human life and death. As civilizations developed, so did astronomical knowledge. The Babylonians created the first star catalogues, tracking the positions of planets and stars with impressive accuracy given their limited technology. The Greeks developed mathematical models of the heavens, attempting to explain planetary motion through geometric constructions of circles within circles. Islamic astronomers during the medieval period preserved and expanded upon this knowledge, creating better instruments and more accurate tables of stellar positions. The European Renaissance brought a revolution in astronomical thinking. Copernicus proposed that the Earth orbited the Sun, not the other way around, overturning centuries of received wisdom. Galileo's telescopic observations supported this heliocentric model and revealed that the heavens were far more complex than anyone had imagined. Kepler discovered that planetary orbits were ellipses, not circles, and derived mathematical laws describing planetary motion. Newton explained these motions through his theory of universal gravitation, showing that the same force that makes an apple fall from a tree also keeps the moon in orbit around the Earth and the planets in orbit around the Sun. The 19th and 20th centuries brought even more dramatic advances. The development of spectroscopy allowed astronomers to determine the chemical compositions of stars, their temperatures, and their velocities. The discovery of the relationship between a star's spectrum and its intrinsic brightness enabled astronomers to measure distances to far-off stars and galaxies. The realization that the universe is expanding led to the Big Bang theory of cosmic origins. The development of quantum mechanics and nuclear physics explained how stars generate their energy through fusion. Radio astronomy, infrared astronomy, X-ray astronomy, and eventually space-based observatories opened new windows on the universe, revealing phenomena that were invisible to optical telescopes. And now, in the early 21st century, we stand on the threshold of new discoveries. We have detected thousands of exoplanets orbiting other stars, confirming that planetary systems are common throughout the galaxy. We have photographed a black hole's event horizon, seen gravitational waves from colliding black holes and neutron stars, and peered back to the earliest moments of cosmic history. We have robots exploring Mars, probes studying Jupiter's moons, and telescopes observing the most distant galaxies in the universe. We are living in a golden age of astronomy, a time when our understanding of the cosmos is expanding more rapidly than ever before. The Hyades cluster has been part of this journey of discovery. It has served as a calibration standard, a test case for theories of stellar evolution, a laboratory for studying open clusters, and a stepping stone to understanding the structure and history of our galaxy. The knowledge we have gained by studying these stars has rippled outward, informing our understanding of the entire universe. This is the nature of scientific progress. Each discovery builds upon previous discoveries, each answered question raises new questions, and the edifice of knowledge grows ever taller and more comprehensive. But even as our scientific understanding has grown, we should not forget the other ways of knowing that humans have developed over the millennia. The myths and stories that surrounded stars like the Hyades were not mere superstitions or errors to be corrected by science. They were sophisticated systems for encoding and transmitting knowledge, for making sense of human experience, for connecting the rhythms of the natural world with the rhythms of human life. When ancient farmers watched the Hyades and knew that rain was coming, they were practicing a form of empirical observation and pattern recognition that was genuinely scientific, even if they expressed their understanding through mythological language. The poet John Keats, in his famous poem, Lamia, worried that science would unweave the rainbow, that scientific explanation would strip the natural world of its beauty and mystery. But this fear has proven unfounded. The rainbow is no less beautiful for being understood as the refraction and reflection of sunlight through water droplets. If anything, understanding the physics of rainbows enhances their beauty by adding layers of meaning and connection. We can appreciate a rainbow both aesthetically, for its visual splendor, and intellectually, for what it reveals about the nature of light and matter. These two modes of appreciation are complementary, not contradictory. Similarly, the Hyades are no less wondrous for being understood as an open star cluster formed 625 million years ago and slowly dispersing under the influence of galactic tides. The scientific understanding adds depth to our appreciation. It does not diminish it. We can still feel the emotional resonance of the myth of the Weeping Sisters, while also marveling at the physics of stellar fusion and the chemistry of nucleosynthesis. We can use the cluster to time agricultural activities, as our ancestors did, and also use it to calibrate cosmic distance scales and test theories of stellar evolution. The various ways of understanding and relating to the Hyades coexist, each offering its own insights and satisfactions. As you prepare to drift into sleep tonight, You might let your mind wander among the stars of the Hyades. Imagine yourself traveling through space, approaching the cluster from the vast distance that separates us from it. The journey takes you across 153 light-years, through the near emptiness of interstellar space, where occasional wisps of gas and dust float in the darkness. As you approach, the cluster slowly resolves into individual stars, each one growing brighter, their colors becoming more distinct. You pass close by a giant star, its orange surface mottled with convection cells where hot plasma rises from below and cooler plasma sinks back down. You feel the heat radiating from this stellar furnace. Imagine the nuclear reactions occurring deep in its core where hydrogen nuclei collide and fuse with such frequency that the star generates more energy every second than human civilization has used in its entire history. You drift past a close binary system where two stars orbit each other in a graceful gravitational dance, each pulling on the other, their mutual attraction keeping them forever bound together. You watch as a flare erupts from one star's surface, sending a stream of charged particles arcing through space toward its companion. You move through a region where a planetary system might exist, imagining worlds circling their parent star, perhaps worlds with atmospheres and oceans, maybe even worlds where life has emerged and evolved, where beings look up at their own night sky and wonder about their place in the universe just as we do. Finally, you turn and look back toward Earth, toward our sun, which from this distance is just another star among the countless stars that fill the galactic disk. You realize that the distinction between here and there is purely a matter of perspective. From the Hyades, our solar system is just another unremarkable star system, no more special or significant than any other. This realization is simultaneously humbling and exhilarating. We are not the center of anything, not cosmically important or privileged. We are one small part of a vast universe filled with stars and galaxies beyond counting. And yet we are here, we are aware, we can contemplate all of this. And that awareness, that capacity for wonder and understanding, is itself a kind of miracle. Let your imagination continue to roam as sleep approaches. Think about the photons of light currently making their way from the Hyades toward Earth, photons that will arrive 153 years from now, long after we are gone. Those photons carry information about the state of the Hyades stars as they exist right now, in this moment. Future astronomers, perhaps humans, perhaps beings descended from humans, perhaps entirely different forms of intelligence, will capture those photons and learn from them. They will be able to compare what those future photons reveal with what our current observations show, and thus, they will be able to measure how the stars have changed over the intervening time. In this way, astronomical observation creates a kind of temporal connection, linking past, present, and future through the patient travel of light across space. Think about the atoms in your body, the carbon and oxygen and nitrogen and iron that make up your tissues. These atoms were created inside stars, perhaps stars that exploded as supernova billions of years ago, scattering their enriched material into space, where it eventually became part of the cloud from which our solar system formed. You are made of ancient stardust, recycled through multiple generations of stellar birth and death. The atoms in your left hand might have originated in a different star than the atoms in your right hand. You are a cosmic collection, a temporary gathering of elements that will eventually disperse again when you die, returning to the Earth, perhaps eventually to space, where they might one day become part of new stars and planets, and perhaps new living beings. This perspective, that we are temporary patterns of matter and energy, arising briefly from the cosmic substrate and returning to it, is not depressing but profound. It suggests that death is not an ending but a transformation, a return of borrowed materials to the universal pool from which new forms will arise. It connects us intimately with the entire history of the universe, from the Big Bang to the present moment, and onward into the unimaginable future. We are not separate from the universe, looking at it from outside. We are the universe looking at itself, a portion of the cosmic substance that has become conscious and capable of wonder. The Hyades stars, in their ancient patience, have witnessed this extraordinary development. They have watched as a particular planet, orbiting a particular star in a particular corner of the galaxy, gave rise to life. as that life evolved over billions of years from simple molecules to complex organisms, as nervous systems developed and brains became capable of thought and self-awareness, as a particular species began to wonder about the lights in the sky and create stories and eventually scientific theories to explain them. The stars have watched as this species developed language and writing, agriculture and cities, mathematics and technology. They have watched as this species began to understand the stars themselves, to measure their distances and compositions and motions, to realize that those distant lights are other suns, that the universe is vaster and older and stranger than anyone had imagined. And the stars will continue to watch, indifferent but present, as this story continues to unfold. What will happen to humanity in the future? Will we survive and thrive, spreading throughout the solar system and perhaps eventually to other stars? Will we develop technologies that seem like magic to us now? Will we encounter other intelligent species and join some galactic community of minds? Or will we fail, destroyed by our own foolishness or by some cosmic catastrophe, leaving the Earth to recover and perhaps give rise to new forms of intelligence? The stars do not know and do not care. They will shine regardless, following their predetermined evolutionary paths until they too exhaust their fuel and die. But in this moment right now, the Hyades stars shine in our sky, and we are here to observe them and contemplate them and find meaning in them. This conjunction of observer and observed, of consciousness and cosmos, is the essential miracle, the fundamental mystery that underlies all of existence. Why is there something rather than nothing? Why does the universe exist, and why are we part of it? These questions may have no answers, or the answers may be forever beyond our grasp, but the questions themselves are worth asking. They define what it means to be human, to be conscious, to be alive to the wonder and terror and beauty of existence. As sleep approaches and your thoughts begin to drift and fragment, let the Hyades be your companions in the darkness. Imagine them as ancient beings, wise and patient, witnessing the flow of cosmic time. Imagine them as sisters, bound together by invisible threads of gravity and shared origin, gradually drifting apart but never forgetting their connection. Imagine them as rain bringers, as navigational guides, as markers of seasonal change, as servants of all the functions humans have assigned to them over the millennia. And imagine them as they truly are, vast spheres of plasma powered by nuclear fusion, radiating their energy into the cosmic void, temporary structures arising from chaos and returning eventually to chaos, beautiful in their physics and their poetry alike. The night sky above us is a vast canvas on which the universe paints its slow-moving art. The stars wheel overhead in their apparent rotation, though we know it is Earth that rotates, not the celestial sphere. The constellations rise and set with the seasons, though we know these patterns are arbitrary, human constructions imposed on random distributions of stars at vastly different distances. The Hyades, part of Taurus, part of the zodiac, will be visible in the evening sky during certain months and invisible during others as Earth orbits the Sun and our nighttime view points toward different directions in space. This cycle of visibility and invisibility, of presence and absence, mirrors so many cycles in our own lives. Things come and go. People enter our lives and leave them. We ourselves are born and will die. Nothing is permanent, yet everything is connected through the web of causation that links every event to every other event across the vast tapestry of space-time. The ancient Stoic philosophers, observing these same patterns in the sky, developed a philosophy of acceptance and cosmic perspective. They taught that we should accept what we cannot change, that we should recognize our place in the larger order of nature, that we should not be disturbed by external events, but should cultivate inner tranquility. The Emperor Marcus Aurelius, writing in his Meditations, while on military campaign in the 2nd century of the Common Era, reflected on the smallness of human concerns compared to the vastness of space and time. Think of the whole universe as a single living being, he wrote, with one substance and one soul. This perspective of cosmic unity, of recognizing that we are parts of a larger whole, brings a certain peace. Our individual troubles and triumphs are real to us but insignificant in the grand scheme. This recognition need not lead to nihilism, but to a proper sense of proportion, a recognition of what truly matters and what does not. The Hyades have been teachers of this cosmic perspective for millennia. Every culture that observed them, that incorporated them into their practical astronomy and their mythology, was engaging in this practice of looking beyond the immediate, the local, the personal, and contemplating the vast and the timeless. When ancient farmers watched the Hyades to know when to plant and harvest, they were participating in a rhythm larger than themselves, aligning their actions with seasonal cycles that had repeated for thousands of years and would continue for thousands more. When sailors used the Hyades for navigation, they were trusting in the reliability of the cosmos, in the fact that the stars would be where they were expected to be, that the patterns were stable and could be depended upon. When storytellers wove myths about the Hyades, they were connecting human emotions and experiences to eternal patterns in the sky, suggesting that our griefs and joys were not isolated individual events, but part of recurring themes that echoed throughout existence. Modern life, with its constant distractions and its emphasis on the immediate and the novel, can disconnect us from these larger patterns and rhythms. We live in artificially lit environments where the night sky is often invisible. We measure time by clocks and calendars rather than by celestial movements. We are bombarded by information from around the world, an endless stream of news and images and data that can make it difficult to maintain any sense of perspective or proportion. We forget that we are animals living on a planet orbiting a star in a galaxy, that we are subject to natural rhythms and cycles, that we are part of the cosmos and not separate from it. The practice of observing the night sky, of learning the constellations and understanding what we are seeing when we look at stars, can be a remedy for this disconnection. It is a form of meditation, a way of quieting the constant chatter of the mind and opening ourselves to something larger and more enduring. When you look at the Hyades, you are not just seeing points of light, but connecting with deep time, with cosmic evolution, with the entire history of the universe from the Big Bang to the present moment. You are participating in an activity that humans have engaged in for hundreds of thousands of years, connecting yourself to your ancestors and to the unbroken chain of observation and wonder that stretches back to our origins as a species. This connection to the past and to the cosmos can be deeply comforting as you prepare for sleep. Sleep itself is a kind of letting go, a surrender of conscious control, a trust that the body and the world will continue without your awareness and intervention. It can be difficult to make this surrender, especially in times of stress or anxiety when the mind wants to continue working on problems, to worry about the future, to rehearse the past. But the contemplation of stars like the Hyades can help ease this transition into sleep. Their ancient patience reminds us that most of our worries are not urgent, that the universe continues its slow dance regardless of our individual concerns, that we can safely let go for a few hours and allow sleep to restore us. In many spiritual traditions, contemplation of the stars has been used as a path to transcendence, to moving beyond the limited perspective of the individual ego and experiencing a sense of unity with the cosmos. The medieval mystic Hildegard of Bingen described visions in which she saw the interconnection of all things, from the smallest seed to the most distant star. The Sufi poet Rumi wrote of the soul's journey from the material world to divine unity, using celestial imagery to describe states of consciousness beyond ordinary awareness. The Buddhist tradition speaks of the emptiness or interdependence of all phenomena, the recognition that nothing exists in isolation, but only in relationship to everything else. While these spiritual perspectives differ in their details and their metaphysics, they share a common insight that the contemplation of the vast and the eternal can transform our understanding of ourselves and our place in existence. You need not subscribe to any particular spiritual or philosophical system to benefit from this contemplation. The simple act of looking at stars and thinking about what they are and what they mean is itself transformative. It pulls us out of our habitual patterns of thought, our constant concern with practical matters and social dramas, and invites us to consider ultimate questions. Where did we come from? Where are we going? What does it mean to exist? What is consciousness? Is there meaning or purpose to the universe, or is meaning something we create for ourselves? These questions have no easy answers, but asking them changes us, It makes us more thoughtful, more humble, more aware of the miraculous nature of our existence. The Hyades, shining in the constellation of Taurus, have been silent witnesses to countless individual humans asking these questions over the millennia. Each person who has ever looked at these stars has brought their own perspective, their own concerns, their own hopes and fears and dreams. For a shepherd in ancient Sumer, the Hyades might have meant that the rainy season was approaching and the flocks would have water and green pasture. For a sailor in ancient Greece, the Hyades might have meant that storms were likely and voyages should be delayed. For a Chinese astronomer recording celestial positions, the Hyades were data points to be measured and documented. For a modern astrophysicist, the Hyades are a laboratory for testing theories of stellar evolution. For you tonight, as you prepare for sleep, the Hyades might be companions in darkness, reminders of the vast universe in which you exist, teachers of perspective and wonder. Each of these interpretations is valid in its own context. The Hyades are large enough, so to speak, to contain all these meanings and more. This is true of all natural phenomena. They exist independently of human interpretation, following their own laws and processes, but they also take on meaning through human engagement with them. The universe is both objective, existing whether we observe it or not, and subjective, known to us only through our perceptions and interpretations. This dual nature of reality, simultaneously independent of us and dependent on us for meaning, is one of the central mysteries of existence. Philosophy has grappled with this mystery for thousands of years. The ancient Greek philosophers debated whether the world we perceive is real or illusion, whether truth is absolute or relative, whether knowledge comes from reason or from sensory experience. These debates continue in various forms to the present day. Modern physics has added new dimensions to these questions through quantum mechanics, which reveals that the act of observation can affect what is observed, that particles can exist in superpositions of multiple states until measured, that reality at the quantum level is fundamentally probabilistic rather than deterministic. These discoveries do not solve the ancient philosophical puzzles but deepen them, revealing that reality is stranger and more subtle than our everyday intuitions suggest. The Hyades stars, governed by the laws of physics that we have painstakingly discovered and articulated through centuries of observation and theory, participate in this strangeness. At the quantum level, the particles that make up these stars are subject to the same bizarre rules that govern all matter: uncertainty principles, wave-particle duality, quantum entanglement. Yet at the macroscopic scale, the scale of stars and clusters and galaxies, these quantum effects average out and the universe behaves in ways that seem more familiar and predictable. We can calculate the future evolution of the Hyades cluster with reasonable confidence, even though we cannot predict the exact position and momentum of any individual particle within those stars. This interplay between the quantum and the classical, between the microscopic and the macroscopic, between predictability and uncertainty, reflects a deep truth about the nature of reality. The universe is layered, operating according to different rules at different scales. What is true at one level may not be true at another. An electron behaves in ways that violate our everyday intuitions about how objects should behave, yet trillions upon trillions of electrons organized into atoms and molecules create the solid, predictable world we experience. Similarly, individual humans are unpredictable, capable of surprising choices and changes of mind, yet large populations of humans behave in statistically predictable ways that can be modeled and forecast. The Hyades cluster itself is an example of this principle. We cannot predict the exact future trajectory of any individual star with perfect accuracy, because tiny gravitational perturbations and measurement uncertainties accumulate over time. But we can predict the general fate of the cluster, its gradual dispersal, the evolution of its member stars with considerable confidence. The details are uncertain, but the overall pattern is clear. This is true of so much in the universe. Individual events are unpredictable, but aggregate behavior follows predictable patterns. Individual raindrops fall chaotically, but the overall pattern of precipitation follows meteorological laws. Individual humans live unique, unpredictable lives, but populations exhibit regular patterns of birth, death, migration, and change. Finding peace and meaning in such a universe requires accepting this mixture of order and chaos, predictability and surprise. The Stoics spoke of distinguishing between what is within our control and what is outside it, and focusing our energies on the former while accepting the latter with equanimity. We cannot control the stars in their courses, the weather, the actions of other people, the ultimate fate of civilizations or species or galaxies. But we can control our own responses, our choices, our attitudes. We can choose to look at the Hyades with wonder rather than indifference. We can choose to seek understanding rather than remaining content with ignorance. We can choose to connect with the cosmos through observation and thought rather than remaining trapped in the narrow confines of our immediate concerns. These choices, small as they may seem, accumulate into a life of meaning and richness. The contemplation of stars is not an escape from reality, but an engagement with a deeper reality, one that encompasses but transcends the everyday concerns that usually occupy our attention. When you look at the Hyades, you are exercising your capacity for wonder, for intellectual curiosity, for aesthetic appreciation. You are honoring the long tradition of human stargazing that connects you to your ancestors and to the ongoing project of human knowledge. You are recognizing your place in the cosmic story as a brief but genuine participant in the universe's long experiment with complexity and consciousness. As your thoughts become increasingly dreamlike and fragmentary in these final moments before sleep, let the Hyades be an anchor and a liberation simultaneously. An anchor because they are stable, reliable, present in the sky night after night across the seasons and years and centuries and millennia. A liberation because they remind you of the vastness beyond your individual life, the cosmic context in which your worries and concerns are less significant than they seem. You are held by gravity to the surface of a planet orbiting a star in a galaxy containing hundreds of billions of stars in a universe containing trillions of galaxies. This is simultaneously humbling and exhilarating. You are small, yes, but you are also part of this vast cosmic dance. You participate in it simply by existing, and you can choose to participate more consciously through observation, understanding, and wonder. The Rainmakers, the ancient ones called them, the weeping sisters, the bringers of storms and seasonal change. And now we know them as an open star cluster, slowly dispersing, each star a vast nuclear furnace. Both descriptions are true, both honor the Hyades in different ways. The ancient name acknowledges the practical importance of these stars to human survival, their role in marking seasonal patterns, their connection to the water cycles that sustain life on Earth. The modern scientific description acknowledges their true nature as physical objects, their place in the grand story of cosmic evolution, their role in teaching us about the universe. Let both perspectives inhabit your mind as you drift towards sleep. See the Hyades with ancient eyes, as markers of time and season, as mythological figures embodying eternal themes of love and loss and transformation. See them with modern eyes, as laboratories for understanding stellar physics, as calibration points for cosmic distances, as temporary structures in the endless flow of matter and energy through space and time. Both visions are correct. Both enrich our understanding and appreciation. The universe is large enough to contain multitudes, to be many things simultaneously, to offer endless opportunities for discovery and wonder. The light you would see if you looked at the Hyades tonight left those stars during the American Civil War, during the reign of Queen Victoria, during the Meiji Restoration in Japan, during the late Qing dynasty in China. That light has traveled across the void for 153 years, through the near-perfect vacuum of interstellar space, through the traces of gas and dust that drift between the stars, to finally enter Earth's atmosphere and reach your eyes. In that journey, the light has been very slightly affected by the expansion of space itself, though over such a short distance the effect is negligible. The light has been slightly reddened by interstellar dust, though again the effect is small. Mostly the light arrives as it was when it left, a messenger from the past, bringing news of distant fires. When you close your eyes and turn away from the sky, the Hyades continue to shine. They shine whether you observe them or not, whether anyone observes them or not. They shone long before Earth existed, though they were different stars then, earlier in their evolution, hotter and bluer. They will shine long after you are gone, long after everyone you know is gone, long after human civilization has either vanished or transformed into something unrecognizable. This continuity across vast spans of time is perhaps the most profound gift that stars offer to our contemplation. They remind us that we are part of a story much larger and longer than our individual lives, larger even than the entire span of human existence. The universe has been unfolding for 13.8 billion years, and it will continue for trillions of years more, through phases and transformations we can barely imagine. Our moment in this vast temporal landscape is infinitesimally brief, yet it is real and significant, at least to us. We are here, now, conscious and aware, able to perceive and understand, able to feel wonder and joy and sorrow, able to create meaning even in a universe that offers no inherent meaning. The Hyades have taught humanity many lessons over the millennia, lessons both practical and philosophical. They have taught us to watch the sky carefully, to notice patterns, to correlate celestial events with terrestrial changes. They have taught us about the regularity of natural cycles, the reliability of cosmic order, the fact that the universe operates according to laws that can be discovered and understood. They have taught us humility, reminding us of our smallness in the face of cosmic vastness. And they have taught us connection, showing us that we are not separate from the universe but part of it, made of the same stuff, governed by the same laws, participants in the same grand unfolding. These lessons remain relevant today, perhaps more relevant than ever in a world that often seems chaotic and disconnected. We live in an era of rapid change, of technological transformation, of social upheaval and environmental crisis. It can be difficult to maintain perspective, to remember what is truly important, to find stability and meaning amid the constant flux. The stars, in their ancient patience, offer us that perspective. They remind us that change is not new, that civilizations have risen and fallen many times before, that life has survived multiple mass extinctions and will likely survive whatever challenges we face now, though perhaps not in forms we would recognize or find comforting. This long view can be sobering, but it can also be liberating. If we zoom out far enough, most of our daily concerns reveal themselves as temporary and relative rather than absolute and eternal. The political conflicts that seem so urgent today will be forgotten in a century or two. The social anxieties that consume so much mental energy are specific to our particular cultural moment and would be incomprehensible to people living in different times or places. Even the environmental changes we are causing to our planet, as serious as they are not unprecedented in Earth's history. The planet has been hotter before, colder before, had more carbon dioxide in its atmosphere before. Life has adapted to all these changes and will adapt again, though the current biosphere, including humanity, may not survive in its present form. This perspective is not meant to encourage passivity or indifference to present challenges. Rather, it is meant to provide context, to help us distinguish between what truly matters and what does not, to encourage us to focus our energies on things of lasting value rather than on ephemeral concerns. The Hyades will shine regardless of what happens on Earth, but the quality of life on Earth depends on the choices we make individually and collectively. We cannot change the stars, but we can change ourselves and our societies. We cannot stop cosmic evolution, but we can influence the direction of human evolution, cultural and perhaps eventually biological. The ancient observers who watched the Hyades and used them to guide their agricultural activities were engaging in precisely this kind of practical wisdom. They could not control the rain, but they could use their observations of the stars to predict when rain was likely and prepare accordingly. They worked with natural patterns rather than against them, aligning human activity with larger cosmic rhythms. This approach, sometimes called living in harmony with nature, has been advocated by philosophers and spiritual teachers across many cultures. It represents an alternative to the modern impulse to dominate and control nature, to bend the natural world to human purposes regardless of the consequences. The scientific revolution of the past few centuries has given humanity unprecedented power to manipulate the natural world. We have split the atom, decoded the genome, reshaped landscapes, and altered the climate. This power has brought tremendous benefits, but also tremendous risks. We are now capable of causing changes on a global scale, changes that will echo for thousands or even millions of years into the future. The question we face is not whether we have this power, we do, but how we will choose to use it. Will we use our knowledge and technology wisely with humility and foresight, or will we continue to act without sufficient regard for long-term consequences? The stars, including the Hyades, offer no answers to these questions. They are indifferent to human choices and human fates, but they offer perspective, context, and perhaps inspiration. When we contemplate the vast timescales of stellar evolution, the enormous energies involved in stellar processes, the intricate dance of gravity and nuclear physics that governs the lives of stars, we are reminded that the universe is both more complex and more comprehensible than we usually imagine. We are reminded that patient observation and careful reasoning can reveal truths about nature, and that these truths can guide our actions if we let them. The story of the Hyades is ultimately a story about time, deep time, cosmic time, the almost incomprehensible spans of duration across which stars and galaxies evolve. 625 million years is the current age of the Hyades cluster, and this number deserves contemplation. 625 million years ago, Earth was a very different place. There were no land plants, no land animals, no humans, no mammals, no dinosaurs. Life existed only in the oceans, and it consisted primarily of simple organisms, bacteria, algae, early animals without bones or shells. The most complex life forms were sponges and simple worms. The continents were arranged differently, climate was different, even the length of the day was different because the moon was closer and Earth rotated faster. Since the Hyades stars ignited their nuclear furnaces 625 million years ago, the entire story of complex life on Earth has unfolded. Fish evolved and colonized the oceans. Plants moved onto land, followed by animals. Insects took to the air. Forests spread across the continents. Mass extinctions wiped out most species multiple times. Dinosaurs arose, dominated the world for 165 million years, and then vanished in a catastrophic asteroid impact. Mammals, small and insignificant during the age of dinosaurs, radiated into thousands of new forms. Primates evolved, then hominids, then anatomically modern humans about 300,000 years ago. Humans spread across the globe, developed language and tool use, created art and music and mythology, invented agriculture and writing, built cities and civilizations, and eventually developed science and technology. All of this, the entire pageant of life's complexity and diversity on Earth, has occurred during the lifetime of the Hyades cluster. This perspective is dizzying. It reveals how young humanity is compared to cosmic structures like star clusters. It also reveals how much can happen given sufficient time. The evolution of life from simple single-celled organisms to complex, conscious beings took billions of years, but most of that time was spent on the simplest forms. Once complex, multicellular life appeared, evolution accelerated. The last 625 million years have seen an explosion of diversity and complexity that far surpasses anything that came before. And the last few thousand years, the period of human civilization, have seen changes at a pace that would have seemed impossible to earlier generations. The Hyades stars have watched all of this happen, unknowing and uncaring, simply following the laws of physics that govern stellar evolution. They have witnessed the rise of consciousness on at least one planet in the universe, possibly more if other habitable worlds exist among their number or elsewhere in the galaxy. They have witnessed the emergence of beings capable of understanding them, of measuring their distances and temperatures and compositions, of telling stories about them, of finding them beautiful and meaningful. This emergence of understanding, this appearance of consciousness that can comprehend the cosmos, is arguably the most remarkable development in the entire history of the universe. For billions of years after the Big Bang, the universe was a place of great activity but no awareness. Stars formed and died, galaxies collided, black holes consumed matter, and all of this happened without any witness, without any comprehension. The universe was unconscious of itself. Then, at some point, on at least one world and perhaps on many, the right conditions came together to produce life, and life eventually produced consciousness. Suddenly, after billions of years of blind causation, there were beings who could observe and understand. The universe had become aware of itself, at least in a small way, in certain local regions. This transition from unconsciousness to consciousness, from blind physical processes to awareness and comprehension, is one of the great mysteries and miracles of existence. We do not fully understand how it happens. We know that consciousness is somehow related to the complexity of neural organization, that brains with certain structures and processes give rise to subjective experience, but we do not know why or how this happens. The hard problem of consciousness, as philosophers call it, remains unsolved. How and why does objective physical process give rise to subjective experience? Why is there something it is like to be conscious? These questions have no agreed-upon answers, and they may be among the deepest questions we can ask. The Hyades, shining in their ancient patterns, remind us that consciousness, precious and mysterious as it is, exists within a much larger physical universe that does not require consciousness to function. The stars would shine whether or not anyone was there to observe them. The laws of physics would operate whether or not anyone understood them. The universe would unfold according to its own logic and dynamics, whether or not any conscious beings existed to witness and comprehend the spectacle. This recognition can feel isolating. We are not necessary to the cosmos, but it can also feel liberating. We are free to create our own meaning, to decide for ourselves what matters and what does not, because the universe offers no inherent instructions or purposes. Different philosophical traditions have grappled with this freedom and this responsibility in different ways. Existentialist philosophers like Jean-Paul Sartre argued that humans are condemned to be free, that we must create our own values and meanings in a universe that offers no objective foundation for them. Religious traditions have typically posited some form of divine purpose or cosmic order that gives meaning to human existence, though the specific details vary enormously across different religions. Scientific materialism tends to see consciousness and meaning as emergent phenomena, arising from the complex organization of matter and energy, but ultimately reducible to physical processes. Each of these perspectives has something to offer, and none has definitively refuted the others. Perhaps the wisest approach is to hold these different perspectives lightly, to recognize that each illuminates certain aspects of existence while leaving others in shadow. The stars teach us humility about our knowledge as well as wonder at what we have learned. They remind us that reality is larger and stranger than any single conceptual framework can capture, that we should remain open to surprise and mystery even as we work to expand our understanding. As your consciousness continues to drift towards sleep, these philosophical reflections may dissolve into images and feelings, into the wordless awareness that precedes dreams. The boundary between waking and sleeping is itself mysterious, a transition between different modes of consciousness that we make every day without fully understanding how or why. Sleep is necessary for health and survival, yet we do not know exactly what it does or why it evolved. We spend roughly a third of our lives unconscious or semi-conscious, dreaming strange narratives that seem meaningful while we experience them, but often dissolve into nonsense when we try to remember them upon waking. The Hyades will be there when you wake, still shining in their appointed place, having moved slightly across the sky as Earth rotates but essentially unchanged. This constancy across the cycle of your personal sleep and waking mirrors their constancy across the larger cycles of seasons and years and centuries. They are reliable companions in the night, markers of time and space, teachers of perspective and wonder. They ask nothing of you except perhaps your attention and appreciation. They offer in return the gift of their light, their beauty, their ancient presence. Think of all the people who have looked at these stars before you, across all the millennia of human existence. Imagine a chain of observers stretching back through time. The astronomer last night checking measurements with a telescope, the amateur stargazer last week learning the constellations, the farmer last century watching for seasonal signs, the sailors centuries ago navigating by the stars. the ancient Greeks telling stories of weeping sisters, the Babylonians recording stellar positions on clay tablets, the prehistoric humans before writing, before civilization, simply looking up and wondering what those lights might be. You are the latest link in this chain, connected to all who came before through the shared experience of stargazing, of looking up and feeling wonder. And you are connected forward in time as well, to all the future observers who will look at these stars in years and centuries and millennia to come. What will they know that we do not? What technologies will they have for observing the cosmos? What questions will they ask? Will they look back at our era with the same mixture of respect and amusement that we sometimes feel when reading ancient astronomical texts, impressed by how much they got right with limited tools, amused by the things they got wrong? Will they have solved the mysteries that perplex us now? The nature of consciousness, the origin of life, the fate of the universe, the existence or non-existence of other civilizations? Or will they have discovered that these questions have no answers, or that the answers are not what anyone expected? The future is unknown and unknowable, except in the broadest strokes. We can predict that the sun will continue to shine for billions of years more, that the Hyades cluster will disperse over the next few 100 million years, that the universe will continue to expand. But we cannot predict what humans or their descendants will do, what discoveries await, what challenges will be faced, and how they will be met. This uncertainty is inherent in any system complex enough to be interesting. The universe is deterministic in the sense that each state follows from the previous state according to physical laws. But it is also unpredictable in practice because we can never know the initial conditions with sufficient precision. And because small uncertainties amplify over time in chaotic systems, this combination of lawfulness and unpredictability is one of the beautiful paradoxes of existence. The universe is orderly enough that science is possible, that we can discover laws and make predictions. But it is also surprising enough that the future is always open, that new and unexpected things can happen. Life itself is an example of this surprise. Nothing in the laws of physics required life to emerge, yet it did. Consciousness is another surprise. Science and civilization are surprises. Everything that makes human existence interesting and meaningful is, in a sense, a surprise, an emergent property that could not have been predicted from the initial conditions of the universe at the moment of the Big Bang. The Hyades cluster, formed from a collapsing cloud of gas and dust 625 million years ago, was itself a surprise in this sense. The specific details of its formation, how many stars, what masses, what orbital configuration, could not have been predicted with certainty beforehand. The cluster emerged from the interplay of gravity, turbulence, magnetic fields, and random fluctuations in the density of the interstellar medium. Once formed, its subsequent evolution has been governed by deterministic laws, yet the exact trajectory of each star remains unpredictable due to the sensitivity of gravitational interactions to initial conditions. This interplay of order and chaos, determinism and unpredictability is woven through every level of the cosmos. It is present in weather patterns, in the orbits of planets, in the flow of fluids, in the firing of neurons in your brain. It is what makes the universe simultaneously comprehensible and mysterious, knowable and unknowable. We can understand the general principles, the overall patterns, the statistical regularities. But we can never predict everything, can never eliminate surprise and novelty, can never reduce the universe to a simple formula that captures everything. This is not a limitation to be lamented, but a feature to be celebrated. A completely predictable universe would be a boring universe, devoid of genuine novelty and creativity. The universe we actually inhabit is endlessly creative, constantly producing new forms and structures and patterns at every scale from the quantum to the cosmic. Stars like those in the Hyades are part of this creativity. They are structures that self-organize from simpler components, clouds of gas, following physical laws but producing outcomes that are unique and unrepeatable in their details. You, too, are part of this cosmic creativity. You are a structure that has self-organized from simpler components, atoms and molecules, following biological and psychological laws, but producing a unique individual that has never existed before and will never exist again. Your consciousness, your personality, your memories and dreams and hopes, all of these are emergent properties of the complex physical system that is your body and brain, yet they cannot be reduced to simple descriptions of atomic interactions. You are simultaneously a collection of particles governed by physical laws and a unified conscious being with intentions and meanings and values. Both descriptions are true, and neither can be eliminated in favor of the other. This dual nature of existence, simultaneously physical and experiential, objective and subjective, determined and free, is perhaps the deepest mystery we face. The Hyades stars, for all their grandeur and fascination, do not experience themselves. They have no inner life, no subjective perspective, no sense of wonder about their own existence. They simply are, blazing their way through their predetermined evolutionary paths, unconscious and unaware. But you are different. You not only exist, you know that you exist. You can think about your own thinking, wonder about your own wondering, question your own questioning. This self-awareness, this recursive quality of consciousness, is what makes you fundamentally different from stars and stones and all the other unconscious structures in the universe. Or is it? We assume that consciousness is rare, limited to biological organisms with sufficiently complex nervous systems. But we do not really know this. We cannot directly observe consciousness in anyone but ourselves. We infer it in other humans based on their behavior and their similarity to us, and we extend this inference to other animals with varying degrees of confidence based on their neural complexity and behavioral sophistication. But could consciousness exist in forms we do not recognize? Could there be some form of awareness in stars, in galaxies, in the universe as a whole? This idea, called panpsychism in philosophy, suggests that consciousness might be a fundamental feature of reality, present at some level in all things, rather than an emergent property that appears only in certain complex biological systems. Most scientists reject panpsychism as unfalsifiable speculation, and there is no empirical evidence for it. Yet it represents an attempt to grapple with the mystery of consciousness, with the seemingly unbridgeable gap between objective physical description and subjective experience. Perhaps future discoveries will shed light on this mystery. Perhaps we will develop a scientific theory of consciousness that explains how and why subjective experience arises from objective physical processes. Or perhaps consciousness will remain forever mysterious, a brute fact of existence that can be described and studied, but never fully explained. The Hyades stars do not care about these philosophical puzzles. They shine on, indifferent to questions of consciousness and meaning, simply following the laws of physics that govern their evolution. And yet, they have inspired these questions in us, have provoked wonder and contemplation, have served as a focal point for human curiosity and imagination across the millennia. In this sense, even if the stars themselves are not conscious, they participate in consciousness through their effects on conscious beings. They help shape human culture and thought. They contribute to the ongoing conversation we have with ourselves about who we are and where we came from and what it all means. This contribution is not trivial. The stars have fundamentally shaped human development in ways both practical and profound. Practically, they have served as navigational guides, timekeepers, and seasonal markers, enabling agriculture and long-distance travel and the development of complex societies. Profoundly, they have inspired wonder and curiosity, motivating the development of mathematics and science, challenging our assumptions about our place in the cosmos, expanding our sense of the possible. Without the stars, human civilization would be unrecognizably different, perhaps impossible. The Hyades have played their part in this grand story. They have been observed and named and studied by countless people across countless generations. They have been incorporated into myths and used for practical purposes. They have been measured and analyzed and theorized about. They have served as a testing ground for our theories of stellar evolution and as a calibration standard for our cosmic distance measurements. They have taught us about the nature of star clusters, about the dynamics of gravitational systems, about the timescales of cosmic evolution. They have done all of this simply by existing, by being available for observation and contemplation. As you sink deeper into the transition towards sleep, the specific details of all this information may fade, but the essential feeling remains. A sense of connection to something vast and ancient, a recognition of your place in the cosmic story, a feeling of wonder at the sheer fact of existence. This feeling is worth cultivating and returning to, especially in moments of stress or confusion or despair. The stars are always there, patient and enduring, offering their silent testimony to the grandeur and mystery of the universe. They cannot solve your problems or answer your questions definitively, but they can provide perspective, context, and a sense of the larger patterns within which your individual life unfolds. The ancient practice of stargazing, then, is not merely an intellectual exercise or a scientific activity, though it is certainly both of those things. It is also a form of meditation, a spiritual practice in the broadest sense, a way of connecting with something larger than yourself and finding your place within it. Different cultures have approached this practice in different ways, through different conceptual frameworks and with different goals, but the core experience remains recognizably similar across time and culture. The experience of standing beneath the night sky, looking upward, and feeling simultaneously small and significant, temporary and connected to eternity. The Hyades, the Rainmakers, the Weeping Sisters, the open cluster slowly dispersing across the galaxy. All these names and descriptions point toward the same physical reality, but they also evoke different aspects of our relationship with these stars. The ancient names emphasize practical utility and emotional resonance. The modern scientific descriptions emphasize physical understanding and cosmic context. Both are necessary for a complete appreciation. The stars are objects to be studied and understood through science, but they are also subjects of aesthetic appreciation and contemplative wonder. They participate in the realm of facts and the realm of meanings, and both realms are essential to human flourishing. As the last tendrils of waking consciousness dissolve and sleep finally claims you, let the Hyades be a gentle presence in your awareness, a reminder that the universe is vast and old and beautiful, that you are part of it, that morning will come and the stars will still be there, shining as they have always shone, waiting to be seen and wondered at once again. Let their ancient light be a blessing and a comfort, a connection to all who have gazed at them before and all who will gaze at them in the future, a bridge across the vastness of space and time, linking you to the cosmos and the cosmos to you. The story of the Hyades is ultimately the story of looking upward and asking questions, of human curiosity reaching out toward the stars and the stars responding, not with answers but with presence, with the gift of their light and the challenge of their mystery. It is a story that has been unfolding for as long as humans have existed and will continue to unfold for as long as we endure. It is a story about rain and seasons and navigation, about grief and transformation and family bonds, about nuclear fusion and gravitational dynamics, and the evolution of star clusters, about consciousness and meaning and the search for understanding. It is all of these things simultaneously, and it is also simply the story of looking at a small group of stars in the constellation Taurus and letting them inspire wonder. Sleep now, and dream of stars if dreams will come. Dream of ancient observers watching the sky and telling stories. Dream of the vast spans of cosmic time across which stars evolve. Dream of light traveling through space for more than a century to reach your eyes. Dream of the Weeping Sisters transformed into stars, of rain falling on dry earth, of navigators finding their way across dark oceans guided by celestial lights. Dream of the future, when the Hyades will have dispersed and new patterns will decorate the night sky, when perhaps other beings on other worlds will look up at their own stars and feel their own wonder. Dream of the endless creativity of the universe, constantly bringing forth new forms and structures and possibilities. Dream of your place in all of this, small but real, temporary but meaningful, a brief flicker of consciousness in the vast cosmic darkness, precious precisely because of its brevity and fragility. The Hyades will keep watch through the night, as they have kept watch for 625 million years, as they will keep watch for hundreds of millions of years more. They will be there when you wake, still shining, still beautiful, still mysterious despite all we have learned about them. And that continuity, that reliability, that patient presence is itself a kind of blessing, a reminder that some things endure even as everything changes, that the universe continues its grand unfolding with or without our attention, but that our attention makes it meaningful. Makes it not just a physical process, but a story, a source of wonder, a connection between consciousness and cosmos. Rest now in the knowledge that you are part of something immeasurably vast and ancient, that the atoms in your body were forged in stars that died before the solar system existed, that you carry within you the history of the cosmos from the Big Bang to the present moment, that you are the universe looking at itself and wondering what it all means. Rest in the knowledge that the Hyades have seen the rise of complex life on Earth, have witnessed the emergence of consciousness, have shone through all of human history, and will continue shining long after our species has either vanished or transformed beyond recognition. Rest in the knowledge that the search for understanding is itself meaningful, that wonder and curiosity are appropriate responses to existence, that looking at stars and asking questions is one of the most essentially human things we can do. The Rainmakers shine on, pouring not water but light into the darkness, not causing rain but marking its season, not weeping but eternally present, not immortal but enduring far longer than any human lifetime, not conscious but inspiring consciousness in those who observe them. They are companions in the night, teachers of patience and perspective, symbols of the eternal patterns that govern existence, subjects of scientific inquiry and poetic imagination, facts in the physical universe and meanings in the human heart. They are the Hyades, and they have illuminated this night and countless nights before, and they will illuminate countless nights to come. Sleep well, and may your dreams be as vast and strange and beautiful as the cosmos itself.